This video is going to cover the main concepts that we learned in class today on January 19th and January 20th. So we started here with an opening exercise. In 3 minutes, the L train travels approximately 15 blocks. Assuming that the L train travels at a constant rate, how many blocks does it travel in 1 minute? And how long does it take to travel 48 blocks? We actually didn't talk about this 48 blocks part, and you won't see that on your screen. So we can ignore it for now. Complete the table. So there's a hint video here already for you. You'll see that in your Desmos, but I want you to start by pausing this video and going over to Desmos and giving this question a try, just to see what you know. So hopefully you gave this question a try on your own, and you probably will have used our equivalent ratio strategy. We know that our ratio of blocks, I'll do B for blocks, to minutes, M, is 15 to 3. And the first ratio that's unknown is here. It's something to 1, some number of blocks in 1 minute. So we'll follow our usual strategy for finding an equivalent ratio. 3 divided by 3 is 1, which means I'll also divide 15 by 3. And of course, I could have shown this in the table too if I had wanted to. 3 divided by 3 is 1, and 15 divided by 3 is going to give me a final answer of 5 blocks in 1 minute. Now, I also want to know how many blocks I travel in 18 minutes, and I can use the same strategy. I could either say, okay, 3 times 6 is 18, 15 times 6 is 90, or I could say, okay, 1 times 18 is 18, and 5 times 18 is also 90. Either way will work. The key is just that you pick your known ratio. Once you've decided the ratio that you know, that will lead you to your unknown number. Pretty easy, consistent strategy. Now, today, our learning target is, given a ratio table, I can find missing spaces by calculating equivalent ratios. Now that's what we did right up here. Or by multiplying and dividing horizontally, that means side to side, using the unit rate. And you might remember that the unit rate is simply the rate per 1. Now we started with this question. In the do now, how many blocks per minute, now remember that would be the unit rate, did the L train travel? And we can see it right here in our table that's still peeking in the picture. In 5 blocks, or I should say in 1 minute, the train traveled 5 blocks. So we know it's 5 blocks per minute, which I also could have calculated using division, because at the beginning I knew that the train traveled 15 blocks in 3 minutes. So if I had divided 15 blocks divided by 3 minutes, I also would have gotten 5 blocks per minute. Now remember that number. It's going to be important as we move on to the next step. So remember our do now. In 3 minutes, the L train travels 15 blocks, and it moves at a constant rate, so same speed. Remember, I already told you guys we skipped this last question, and we needed to figure out how many blocks it traveled in 1 minute, which we did, and this is what our answers looked like. So this is the table we filled out, and I want you to fill in the third column with the unit rates for each row. Well, we already found the unit rate for 15 blocks in 3 minutes. We just did that up here. 15 blocks in 3 minutes would be 5 blocks per minute. Now, of course, 5 blocks in 1 minute, which is the next row of our table, is literally the unit rate as a ratio. It's 5 to 1, 5 blocks per minute. And we could check our unit rate or our blocks per minute for 90 blocks and 18 minutes, although you can probably see where this is going. Blocks 90 divided by 18 minutes is going to give us, again, 5 blocks per minute. Now, Here's why this unit rate is so important, and you can see it here in the next 2 slides if you want to check it out on Desmos. I made a nice graphic organizer for you, but I'm going to show it all in one table. As we move from minutes to blocks, horizontally, remember, side to side across our ratio table, you start to see a pattern. For every equivalent ratio, you can always multiply the number of minutes times 5 to tell you how many blocks you travel. Now, that makes a whole lot of sense because if you're traveling for, let's say, 3 minutes in minute 1, you would go 5 blocks, plus minute 2, you would go 5 blocks, plus minute 3, you would go 5 blocks. 5 blocks for each minute, which equals 15. And that's why this situation here, 3 times 5 is 15. It makes a whole lot of sense. And that could be said for any of these examples, right? If I go for 18 minutes, each minute is going to be 5 blocks, so 18 times 5 is 90. Now, if I'm working in the opposite direction across the table, I want to move from blocks to minutes. Inverse operations dictates or tells me that I'll have a similar pattern. 15 divided by 3, or divided by 5 is 3. 5 divided by 5 is 1. And 90 divided by 5 is 18. Now, again, this makes a whole lot of sense because if we just use 15 as an example again, right? Let's take it down here to where I have some space. I'm taking 15 blocks and I'm splitting it up into 5 blocks. That'll be 1 minute. Another 5 blocks. That'll be 2 minutes. And another 5 blocks. That'll be 3 minutes. I'm dividing the number of blocks into groups of 5 blocks because each minute has 5 blocks. And so as I'm working across my table, I can always follow this pattern. I can multiply 3 times 5, I can multiply 1 times 5 or 18 times 5. And if I'm moving in the other direction, I could simply use division. Why is this so helpful? Well, let me clean up a little bit so I can have some room to show you. Let's say someone asked, hey, I need to go a total of 25 blocks on the L train. Well, instead of having to pull out 25, do this whole arrow business, find an equivalent ratio, I could simply say, oh, well, I know that I can always divide the number of blocks by 5, and that will tell me the number of minutes it takes. In this case, 5 minutes. Similarly, if someone said, hey, I have only, I don't know, let's say 20 minutes to ride the L train, how many blocks am I going to be able to go? Well, every minute you go 5 blocks, so you can just multiply 20 times 5 to get a total of 80 blocks, right? And so the important thing to realize is that we're talking about a pattern between blocks and minutes as opposed to an equivalent ratio, which shows the relationship between 2 different sets of blocks and minutes. And so this is a lot easier of a way to fill out a ratio table, and it's what the rest of today's practice is focused on. So make sure you read the directions below this video, and you'll be able to jump in and get started.